So anyway, as I started to say, this is a presentation called the SQL Server PostgreSQL Throwdown. A little story behind that. About 4 years ago, and it was probably a little bit longer, the company I worked for was developing some systems which they wanted to use AWS Aurora. Now, Aurora is the AWS's souped up version of Postgres. It's 11 times faster than regular Postgres, and they got their own hooks into it to make it really efficient. So I was asked to support it, and I did. Then the request shifted to straight Postgres because of the need to be on-prem as well as in the cloud. Now, with Aurora, it'll replicate to other recovery zones within AWS, but does not replicate to on-premise, which we require that. And need that because of the fact of what we do. So we switched to that, and is the requirement. But anyway, always in the back of my mind was, why Postgres? I mean, I'd never heard of Postgres. And they said, why not SQL Server? Not that, hi, welcome. Not that I get a commission from Microsoft or anything, or those that use SQL Server, but SQL Server was always my wheelhouse, and so I was kind of miffed that nobody talked to us. You might say, well, hey, let's ask database administration and see what they say. Said no C-level exec ever. The fact is, folks, they just don't do that. The DBAs aren't consulted at all, usually. And that's just the way it is. So I decided I'd throw together this presentation about, and called it a SQL Server Postgres Throwdown. Something on the order, I don't know if you ever heard of Bobby Flay. He's a famous chef. And he has, or at least he used to have, a cooking show where he'd do these throwdowns. He'd invite a guest chef on there, and they would both make the same recipe. And they had an independent third party. I'd hate to be in that person's shoes, but they would judge between which one was better, Bobby Flay or the guest. So this is something on the order of that. So let's go on a little bit of history about Postgres. The Postgres project was led by Professor Michael Stonebreaker. Never heard of him, but and it was a project that was sponsored by the Defense Advanced Research Projects Agency, or DARPA, and the Army Research Office, as well as the National Science Foundation and ESL Incorporated. And the implementation of Postgres began in 1986. So Postgres was developed to address the limitations of its predecessor, which was Ingress, and is aimed to better handle complex data types, which we'll get into those data types in a little while here.
I get it. Ingress, data coming in. Postgres, after ingress. Somebody's thinking over there in DARPA.
I didn't realize that till you said it just now. But yeah, you're right. So hence the name. So anyway, by 1996, the Postgres project stabilized and morphed into PostgreSQL as it's known today. So the history of SQL Server started out as the Microsoft SQL Server product, SQL Server 1.0. And it was for a 16-bit server for the OS/2 operating system. Boy, that's going back some. That was back in 1989. And then it extends to the current day versions of SQL Server 2019 and SQL Server 2022. So as a raise of hands here, does anybody use Postgres? And okay, and what about SQL Server? Okay. So let's get into the costs. Postgres is an open source database system, which means it's free to use. That's kind of a tough price to beat. And there's a community that actively contributes to the development of it. SQL Server is developed by Microsoft, as I said, and it's a commercial product. Excuse me. And so license fees are going to apply. In other words, it's not free. And it's tightly integrated with the Microsoft technologies. So yes, Postgres is free, but the open source version is definitely free. But if you get if you've got to run in a production system, you have a support issue at 2:00 in the morning. I don't think you're going to get any support from the Postgres community. So I don't know, this is more, and I should say, starting off that I'm kind of bigoted towards SQL Server. So I should have said that at the beginning. So, don't get up and walk out on me. It's change is hard, but I'm getting there. So anyhow, is that so if you've got an enterprise where your bread and butter is the backbone of it is Postgres, you may want support. So there are paid versions of Postgres which are available, and my company purchased that. It's still cheaper than SQL Server Enterprise license, which a 2-core pack of SQL Server Enterprise is approximately 15 grand. The Enterprise edition of EDB, which is the commercial Postgres, costs close to 14 grand. So the first round will make PostgreSQL the winner by $1,000. So then there's Postgres uses MVCC, which is multi-version concurrency control. Allows multiple users to access the database simultaneously. And without risking data integrity or consistency. And it maintains this consistency through using a multi-version model. Each transaction sees a snapshot of the data as it was, some time ago. And so Postgres keeps multiple versions of a data row tagged with the transaction IDs. And I think that saying a data row is incorrect. I believe that that should be, it's called tuples. But it provides a consistent view of the database at the start of each transaction. So it's like Oprah Winfrey. Everybody gets a copy. Nobody gets locked out. Well, big deal. So does SQL Server. SQL Server actually had this ability since SQL 2005. Now, by default, SQL Server doesn't use MVCC, but it supports it with the snapshot isolation level, which enables it. So when you enable snapshot isolation, SQL Server maintains different versions of the data rows. This allows concurrent read and write operations with reduced locking contention and increases performance. So how do you set that up in SQL Server? Well, at the database level, running these two DDL commands to alter the database to allow snapshot isolation on, and also to alter the database to set read committed snapshot on. So allowing snapshot isolation on activates snapshot isolation. Read committed snapshot on replaces the default read committed behavior with snapshot isolation. So I was kind of curious about that, so I set up a little lab. So I thought do this. We'll run this in Postgres. We'll run something in Postgres and do the same thing in SQL Server with this. First with snapshot isolation off, and then with it on. So I want to go to the elephant first. So in PostgreSQL, I've got this database called My Database. And I'm going to do a begin transaction to delete an entry from the from table A. And this is kind of set up based on my hobby. And my spare time, I study Chicago organized crime. So what we've got here is a mob capo, and he was called Joey the Clown Lombardo. He, of course, died in prison, but as he should have. So I'm going to start this, and I'm not going to do a rollback or commit. I'm just going to leave this hanging here. And so he says that he's deleted one row, but he really hasn't. Then we're going to do a query. And so I'm going to list the contents of table A. While the delete is just sitting there hanging. So I do that and we've got two rows here. That well, it should have been three. Joey the Clown Lombardo should have been here as well. I think I accidentally deleted them. Oh well. At any rate, you can see that we see the contents of the table, regardless of the fact that there's still a delete hanging there. So anyhow, I'll go back and clean that up later. So now let's do the same thing with in SQL Server. Now I've got two databases. I've got one using the traditional with the no snapshot isolation level set on. We'll start with that. We'll load my my delete. And here's the same delete of Joey the Clown Lombardo. Then I'll also do a load of the query, which is going to cause basically the query to hang. I'll do a begin transaction. I'll do the delete, but nothing else.
Can you zoom the text in more? Thank you.
You're welcome. And thanks for asking. So here I'm gonna go and, I'm gonna run the begin transaction and the delete. Oh, I see what happened. Okay, one row affected, but it's just hanging there. You know, I haven't done a commit. I haven't done a rollback, I haven't done anything. And so now I'm gonna do the query where I'm going to list the contents of that table. And what's happening is that this thing's going to continue to run. Because we've got this delete statement here that's got it locked. So I'm gonna go ahead and do a rollback here. And once I do that, you see the contents of the table. And that is kind of small. Let me
It will not, you won't make that bigger, I don't think.
well, I was going to do it with zoom.
Oh, is it?
That's not what I wanted. Yeah, I don't think it's running. That's not what I wanted.
Got something really interesting there. You must have hit a shortcut I didn't know about.
Yeah, it's me either.
But does everybody see kind of what happened there? So when you do a delete, typically on a transactional database in a read committed isolation level, which is the default here, a delete takes an exclusive lock, right? It's basically saying you can't read this because I'm changing it, I'm doing something to it. So nobody can read it, right? And so that's why his select query was hung there, because the transaction was in an open state since it was never committed or rolled back. It was just holding that lock. As soon as he rolled back the statement, the lock was released, and that other query just instantly finished.
Yep. So now, just like on the cooking shows where they have a recipe already prepared to show you, they take one out of the oven as they put the one that they're preparing in the oven. Well, I've got a database prepared with snapshot isolation level set called My Database. And we're going to run the same thing. So I'm going to run this delete transaction against My Database. Again, doing the just the begin transaction and the delete, just like I did before. And we get the same one row affected, but it's just hanging there because I haven't done a rollback or I haven't done a commit. And so when we go and run this query against My Database, we should get the all the contents. Just like we did in Postgres.
Hey, your Zoom worked.
Yeah, I started it. So there, are there any questions?
There's one thing to know about read committed snapshot isolation, or RCSI. And that is, it's great because now writers don't block readers. But it's something known as, I want to say, pessimistic concurrency, meaning that it's assuming that the data is not going to change. If something was locking it, it's reading old data. So let's say somebody's running an update on a financial statement, right? So we're updating your balance, and you go and you look at your balance, and the update that comes in at the same time you're looking at your balance, you are not going to see the results of that update, right? So oftentimes financial institutions don't want to do this. They'd rather you wait until the right data has come in and then get it, right? So you're sacrificing now performance or time or latency for accuracy, right? But at the same token, some might argue, well, if you would have wanted to look at your balance a split second later, that update would have occurred. If you would have looked at it a split second earlier, that update was never even issued. So does it really matter? It's a race condition, it's timing, right? But it's important to understand that because of the fact that when read committed snapshot isolation is not reading maybe, some would argue, true data. Other people would argue, well, it's not committed yet, it's not true. So it's just good to understand.
Go right ahead.
I was just gonna say that this is exactly what our biggest issue at my current job is we have an e-commerce site that has tons of flash sales. And their business model is if we're selling 100, we're only selling 100, not 101. So we have to have the table wait to read the quantity left after the customer purchases, and it inserts to the transaction table. And for every customer who's on the site, they have to refresh. They see there's 98 left because there's 2 transaction rows. And although we're trying to push them, hey, the table locks because it's trying to read and write at the same time. We're saying, no, we have to have absolute consistency. So we just had to have that in place where it locks on inserts.
Yeah. And so you would certainly not want read committed snapshot on, at least for that. The other thing that you do, right, is you could take a table lock every time that you write so that nobody else can write to that table. They're going to have to wait, right? You can even set, if you wanted to go this far, right, you could, I think there's a way to basically only allow so many rows into the table. I forget how to do that offhand, right? But it's now you're talking about controlling that kind of stuff at the database level, which is great for safety, but at the end of the day, it should be handled in the application. Now, in your case, you can go so fast, right? I mean, if there's 100 people and they all click on buy at the same time,
Right.
What happens to that 101st person, right? And so you need as many controls as you can.
Yeah, we do have application level work because on the flip side, after the insert, we have to count again and
Right.
automatically void it if it's over that 100.
Yeah.
But it's interestingly, as we fixed the performance of the site, the problem kept coming back because you had more of the concurrent purchases then because people weren't spinning for 20 seconds trying to purchase something. So it's just interesting that this is exactly what we're dealing with.
Yeah.
Mm-hmm. Yeah, it's there are trade-offs. Yes, sir.
You mentioned this behavior kind of being a default within SQL Server, but an option you can actually make it function the way Postgres does.
That's correct.
Yeah.
I guess my question would be, is that somewhat kind of determined by other factors in the way the engine works or something? Do you feel that's more of just about supporting perhaps like legacy? Like, why would they necessarily kind of pick 2 different defaults in some sense? Or
SQL Server, so first of all, just to be clear, SQL Server's default is not read committed snapshot isolation.
yeah,
Postgres
got that.
is, and in fact, I think Postgres, can you turn it off?
No, you can't.
Okay. So in SQL, read committed.
Hmm.
Why? Because if you look back in history, in isolation levels, you had serializable, repeatable read committed, and read uncommitted. Okay. And so, and then read uncommitted, I think that's it. So read committed was the standard in relational databases. And I think probably today, still today, it is because it gives you writers block readers and readers block writers, right? And so that's just the accepted consistency because it means that you're only reading data that has officially been written and committed. And if you're reading something that is in process, you're going to wait because something is happening. Could be rolled back. It could be committed. Nobody knows, right? It's Schrodinger's cat. But we're not going to open the box. We're just going to wait for everything to happen. Okay, so that's read commit, and read committed is still considered, the standard. So only do you turn on read committed snapshot isolation if you accept the fact that you are reading snapshots of the rows at the time that you ran your read query. And you will not be waiting if something is in process, which means in a second later, what you just looked at a second from now might not be correct. Does that make sense?
It does.
That's the question.
Then I feel like you're saying in general, kind of the field or, SQL in general kind of has this preference in the direction of the way SQL Server handles it, or like just a common kind of default. Postgres kind of being opposed to that. Were they in some sense trying to solve a different problem, or like it seems weird that a big open source project would kind of take a view counter to what makes sense to me. Like I understand why you're saying, it went that direction.
I've got a thought. I don't know if you've got a thought or if you know.
No,
My thought is just this. This project, if we go back to the beginning slide, this project started from DARPA.
Mhm.
So they had a specific use case that they were developing this
Yeah.
database for.
Some early
Right.
requirement on.
It wasn't necessarily designed for the masses. It was designed for them. And maybe that's why. Maybe it wasn't like that at first. I don't know. Maybe the open source. But the other thing is, anytime you are dealing with read committed, serializable or other, right? You have to have a lock manager. And so you have to block things, right? And SQL Server does that. I mean, okay, I'm going to stop after this because this gets way too deep. But SQL Server does that with exclusive locks, shared locks, and intention locks, right? And intent are lock escalation. So for instance, if I take an exclusive lock on a row, I get an intent exclusive lock at the table level. Because if somebody wants to come in and take a table lock, they won't even be looking for row locks. So by the nature of locking a row, I have to have an intent lock every level higher than it in the hierarchy to prevent something that is going straight for a higher level lock from being able to lock that, right? Because if I'm locking a row in a table, you can't come in and lock the table. That doesn't work, right? So we have to have and there's a whole threaded process called the lock manager within SQL that has to manage all this. So the higher concurrency, the more busy your server is, the more busy the lock manager is, which can cause performance problems, right? So Postgres, they might have said, doesn't matter to us. We don't need to manage this the same way. Right? But there's a trade-off too, because when you're doing snapshot isolation, that means you need to keep a snapshot of that record as other transactions come in to write.
Sure.
Right? And if there's
Kind of
multiple
situation, I would think you could potentially have tons of different attempts to read or attempts to write, and then somehow need to rectify that, with
well, they'll all read from the same, what do we call it? Version records. Right, so in SQL, it's in TempDB. I don't know where they put it in Postgres. I assume Postgres has a TempDB.
yeah, they do. But actually what I think is in the, it's actually in the data itself. It just makes an extra copy.
And then keeps like a row version in
Mhm.
the same table
Yeah,
or on the same page.
yeah. And then when it's done, it'll tag delete. And I think it comes back and, I'm still learning Postgres. So I don't want to get into too many details because I might tell you something wrong. And if anybody wants to correct me, feel free. But that's my understanding of it. But getting back to SQL Server and the original way of locks, I mean, it's not just SQL Server we're talking about, every DBMS. Except for Postgres. It's a type of locks. So Postgres was the one that came out with something different. And SQL Server came along and said that, well, yeah, hey, we'll do that too, if that's what you want. So getting back to our throwdown here. So I would say that round 2 is a draw. Because Postgres can do that, but so does SQL Server. So data types. I'm gonna blow this up. These are the data types. I'm not going to get into explaining these, but this just gives you an idea of the data types you have with Postgres. I pulled these right out of the manual.
They have a data type for IP address?
Yeah,
Interesting.
but the ones we use quite a bit are this JSON-B. It's kind of like XML, but it ain't. So SQL Server data types, not quite as many. There's more of a, the standard type of offerings. So round 3, PostgreSQL is the winner when it comes to data types. So now, recovery. Recovery is a big part of what I do as a DBA. Practice it and be ready for it or when it happens. And we're going to see here that it's different than any other DBMS, but I digress. So recovery for Postgres uses a wall, right ahead log file. And at all times, Postgres maintains that in the PG wall subdirectory of your databases directory. And records every change made in the of the database files. It exists for crash recovery purposes. And then what will happen is it'll restore consistency by replaying the wall. The wall instance level is at the instance level, so all databases in your instance is going to be recovered, like it or not. So in fact, the best practice dictates that you have one database per instance because of that. So to do recovery, you end up combining a what amounts to a file system backup with the wall files. Then you take the file system with such as tar and with the backups. And I'm going into Linux here. And to do recovery, you restore the file system backup, and then you end up replaying all the wall files to bring the system back to the current state or to recover to a specific point in time. And you do that by specifying the desired stopping point by date and time or a named restore point or a completion of a specific transaction ID. And the only recovery I've ever done has been in practice, and it's been with the date and time. I haven't done the others.
So when you say file system backup, you mean like the data files? I'm assuming you don't have to back up the OS per se, but the data files.
Yes, and I'll get into that in a minute.
Okay.
The, it's different. So Postgres will replay the wall entries up to that point and give you a consistent snapshot of the database as it was at that point in time. So the benefits is you don't need a perfectly consistent system backup. As a starting point, the log will replay and corrects any internal inconsistencies. So it's got that going for it. Continuous backups are done by archiving the wall files. And so you can restore to any point in time since your base backup was taken. And then the note here is that pgdump and pgdumpall do not produce file system level backups for continuous archiving. They're logical dumps and lack enough information to do a wall replay. So what we end up using, and I forgot to put that in here, is that you use something called PG underscore base backup. And what that does is that does a whoops, dadgummit. That does a ends up doing file system backups of the of Postgres, the data and the wall records. So the disadvantage is that it's the recovery is complicated. And it was for me. I just did one this week. We do practice recovery drills so that it hones our skills so that should we have to do a real recovery, we can just, there's no him and hawing, it's, we're on it. And when it comes to recovering Postgres, it's a little more complicated. So I at least didn't move that fast. There was a lot of recoveries and a lot of failures before I finally got it right. And as I said before, recovery is done at the instance level. So if an instance has 3 databases, all 3 databases are getting recovered, like it or not. And recovery is a kludge. And I'll demonstrate that here in a minute, or not do an actual lab, but show you what I mean. So we do a recovery. I do a change directory. I'll blow this up a little bit. So I'll do a change directory to where the last base backup was taken. And then what I do is next is that where I'm restoring this to, I remove all the files that's sitting there in that instance. So this is the nucleus of where the database files are. I remove them all because they're going to be recovered to my base for my base backup. And here's where I unzip the base backup. I put that in that location there. And then I do the same with the wall files. Then there's after that's recovered, I then go into postgres.conf, which is the configuration file. And I uncomment this, which is going to take all the backup archive files and recover those. And I change the, or I set up a recovery target time to the point in time before the, whatever it was bad that happened. And then restart the instance. So if you notice one thing, in every DBMS that I've ever worked in, your recovery is done within the DBMS. I got to restore a database. I do that within the DBMS. I open up a query window and do a restore. And I don't care if that's, if you're talking about SQL Server, you're talking about DB2, which I've supported quite a bit of, whatever. That's the way it's done. It's kind of a standard. But not so with, Postgres. Why it's done this way? It's almost like, and I'm not picking on these guys, but it's almost like, they got this all developed and they said, hey, we have to figure out a way to recover in case this crashes. Or in case we have to restore to a point in time. And the other guy said, well, how are we going to do that? You know, so it really, recovery seemed like it's an afterthought. So let's talk about SQL Server recovery. And but the recovery's at the SQL Server, the recovery's at the database level. Each database has its own log file. So that if I've got 3 databases, I'm only recovering one database, the one with the problem. Each, like Postgres, I have to have a full database backup as a starting point. And then I recover, specifying that full backup and any log files to do a point in time recovery. So each database is recoverable independent. No need to shut down the instance on the database as the recovery is done online. You can also do accelerated data recovery. So fast and consistent recovery regardless of the number of transactions. And then there's the ability to do file and page restores. I've never had to do that myself, but it is available. So here's an example of doing a SQL Server recovery. I would just restore, in this case, my database 2, then from the full backup. Now, if I had log files that went with that in doing a point in time recovery, I would have those in here as well.
So let me ask you a question. So in Postgres, when you are doing these wall files as part of your restore, is it just one? Or is it like SQL? And for those of you who aren't familiar with SQL, when you apply transaction logs to a backup file, they are incremental, right? So if you're taking log backups, let's say every 15 minutes, what you are doing is you are restoring this 15 minutes, then you're going to go and do the next 15 minutes, then you're going to go and do the next 15 minutes, right? So they're incremental. So is the wall file in Postgres, you're just going to pick the most recent one because it's got everything, or how does that work?
Well, it works with you archive them.
Oh, when you archive them, it's kind of like a checkpoint to say, okay, we're starting a new one.
Yeah, something like that. And so he takes the archives into account when the recovery is done.
So it's kind of, an archiving is kind of like doing a transaction log backup. It's taking the portion of the log that has not been backed up and backing it up so that you can reuse the file.
Yeah, but my whole pet peeve with Postgres is that the recovery is just, and it's complicated.
Yeah.
And it's not quick. Now, I suppose I can do some things, write some scripts to make it work faster by feeding the script some parameters. And then I can go in there and I can do things like edit the configuration file, do all this behind the scenes.
Which is, my guess is in Postgres Flex Server, which is our Azure offering. When you go in there, you want to restore database. You're basically just saying, giving it some Azure commands. Hey, restore my Postgres to this point in time. Behind the scenes, the Azure backend is probably doing all this. I mean, it has to, because it's using the same code base. It's Postgres.
Mhm.
That's crazy.
And if it's anything like AWS, what it does is when you do the restore, it doesn't restore over the instance.
Creates a new.
It creates a new one.
Okay.
So round 4, I say SQL Server scored a knockout. Now, here again, I said at the beginning, I like SQL Server. I don't like Postgres. Now I'm getting to warm up to it. At the end of the day, it's another DBMS to put on my resume. But not that I'm planning on going anywhere else. I mean, at my age, I'll probably stay at the OCC till they say it, you need to go. But yeah, and these little drawings that I did, just as a kind of a side note, a fun fact, I used Copilot to draw 'em. I would say, hey, give me this last one. He didn't do it right. I wanted Clippy to do a knockout of the elephant, but somehow I got this thing with the big ears. You know, oh, okay, great. You know.
Clippy is a copyrighted figure. So that's probably why Copilot would not.
Well, he used it for the others.
So let me ask. You're a database administrator. Anybody in here a developer that develops on Postgres? Oh, shucks. I was hoping to get some answers. Because like my question around Postgres is so many people are using it. There's gotta be a reason why. From an administrative point of view, and I was a DBA, I could see this being a nightmare, but I was also a SQL developer. What do you hear? Do you hear anything from them as to why did they choose it? Did it, I mean, I'm assuming it wasn't just top down. Somebody went to somebody and said, hey, we need to start using Postgres.
Well, it started out, it was top down.
Okay.
And the guy that chose it used to be a SQL Server DBA,
Okay.
believe it or not. But what he liked it for was this goes back to Aurora. He said, yeah, we're going to use Aurora because it's 11 times faster. And it is, it's a beast. But then, you know, the SEC comes along and says that, well, that's fine and dandy, but you have to have the same thing on-prem. So in case AWS goes down, and it has, you know, to their credit, I mean, it has. And folks, you know, we work in an industry that we can't have any downtime. So, you know, it's we have to be able to if AWS is down, be able to fire up and run our systems on-prem. So the now that ain't everybody, but that was how it all started. So he figured that, well, you know, we're going to use Aurora, and then all the development is done using Aurora style Postgres, and the on-prem that we ended up using standalone is the same thing. There was no coding changes, so there was no loss of time.
Got it. Okay. So one thing I will throw in there that I don't know too much about these, as I'm currently also just beginning to learn Postgres because lots of my customers use it. Postgres has extensions, and those extensions can offer a lot of different and interesting functionality built on top of the database platform, right?
Absolutely
So
correct, yeah.
just like with any program that's got extensions, especially open source. Anybody can write extensions. If they know the code or the language that is written in, they can write an extension for it and then put it out on the market, right? Now, I know in Microsoft Azure for our Postgres Flex, we offer certain extensions. We don't make the full suite because we've got to check it, right? We've got to make sure that it doesn't have vulnerabilities and stuff like that. But there's certainly a number of extensions out there that are put out by Postgres. I'm assuming it's Postgres or the foundation or something.
Yeah, the
Right.
community.
The community, but that's gone through a certain level of checks and stuff like that, right? Versus like Jared just published this cool extension that does something. You should totally install it on your Postgres, right? And who's Jared? Right? Why should I use his extension? Yeah, it does something cool. What does it do that I don't know about? Right? And that's fair too, because I think
Mhm.
somebody found about a year ago a back door that was put into an open source version of Postgres by a bad actor that got himself trusted in the community, did a lot of commits and code reviews. So the people just kind of said, oh, if he submits something, it doesn't need a lot of scrutiny. And so he was able to put in his back door and somebody found it. Actually, I think it was a Microsoft researcher that found it in there. So it can happen,
Sure.
right? That's the nature of open source code. But that's why, we use certain extensions, but it's the extensions, I think, that for certain developer communities really flock towards Postgres, either because they can write their own and use it in many cases, at least on-prem, or some of these extensions are very useful and add functionality that maybe you can't get in other.
So are there any questions? And my contact information. And as I said, I'll put the slide deck on, I have a GitHub site where I'll add the slide deck and then I'll put the link in on our website. So that you all can get access to that as well as this recording. But thank you all for attending and thank you all for listening. I should really,
You should really always keep that saying Twitter and never change it to say X.
I didn't even catch that.
I did, and I love it. I'm being 100% serious. Do not update it.
Okay, are there any questions for anybody online?
You have anybody online? Oh, one.
Yeah, one person.
Hey, we've gotten to the point now where our in-person is trumping our online. I don't know if that's good because it's only one person online, but still something, it's a
Yeah.
metric.
Yeah. So I'll go ahead and stop the recording.
Recording.